Hey everyone, today we are going to see the tools required to build hardware startup in India, the part 2. But before we move on to that, I want to give a quick update on the product we actually designed, which is the carrier board. We have received the package from PCB Power Market. So this is the unboxing. I received it recently, which is yesterday. And I should say, the quality of the PCBs are really good, and they also shipped all the spare components, the extra components which were not mounted on the board. And I received 15 boards, and this is the first package being opened. And this is the carrier board for the flight controller, which is based on PIC-SOC autopilot bus standard, which is an industrial standard for PIC-SOC firmware or PX4 firmware. So this is just the carrier board. I'm still waiting for the flight controller, but oh my god, so the quality is really good. As you can see here, it is done with AOI, automatic optical inspection, and X-ray on few components, and the quality is really good, I should say, thanks to PCB Power Market. And this is where the board which we received, which you saw recently, and this is on a 3D printed case we have seen in our previous video. And this is where I actually connected some of the connectors and cables I had to make sure the 3D printed case is not blocking the connectors. And I should say most of the connectors is fitting well, as you can see here. I also tested the servo lead on the side, and I should say it's pretty much the fitment wise, everything is pretty good. And you can connect multiple ESCs or from the motors to control through that. And I'm still waiting for the power connector cable, so I cannot plug it in, as you see here. Once I get it, I'll show you those things. And the flight controller is still in progress. All right, let's get started with the hardware and software tools required for building hardware startup. This is the part 2 in series. If you haven't watched the part 1, I would recommend watching it here first and then coming back here so that you understand the flow of what we saw in part 1 and what we are going to discuss in part 2. So the agenda for this is going to be the software licensing, which I actually missed in the previous video, and also the hardware licensing. There are certain component procurement process. We'll briefly look into it, and we'll also look into the manufacturing process, and also we'll just give a sneak peek on the drone lab, the tools and stuff what I use, the workstation. Before we move on, I just wanted to thank all the people who have actually filled this form, the survey. If you haven't done it already, I'll put the link in the description, and you can also scan the QR code. Anyone who is interested in building drones or interested in buying one for aerial photography and videography, drone enthusiasts, or a professional pilot who wants to own a drone, especially in the nano category, I would recommend you to fill this form so that we understand what sort of market is required to be tended. So just make sure you do it. Let's move on to it. So we saw in the last video about the softwares, the MCAD, ECAD, and the IDEs. As I said before, I've used Fusion 360 for the last 6 years, and it has student license and academic licenses free of cost. And for even enthusiasts and hobbyists, there is a version which is free, where you can learn all this stuff. The basic design tools and features are available. There are some advanced features which are actually logged in for paid version. But anything to begin with is really good. Fusion 360 is really lightweight software. It doesn't take too much of resources on your computer. It's a cloud-based also, so you can connect. You can install your app on the phone, and whatever you design on the computer, you can also view it on your phone right away. And on the ECAD, which is electronic computer-aided design, I've been using Altium Designer for the last 3 to 4 months now. It's a paid version, unfortunately, it's super expensive to begin with. I would recommend going with the KiCad, which is like free and open source. It has like all the tools and features what Altium Designer has. It's just that Altium Designer is focused more on professional side, and also some of the designs I work with is like too complicated to work on KiCad. So Altium Designer has like more features. Again, if you're a beginner or like you're doing the basic designs, KiCad is far and better with respect to the cost and the effective utilization of the software itself. And coming over to IDE, as we discussed in the previous video, there are different IDEs for different programming tools, programming languages. The ones I use are Visual Studio and PyCharm. I would recommend Visual Studio, the community version, which is free, and there is a professional version, which is like the paid ones. The community version has like a lot of features, and PyCharm for Python or like development of AI tools and so on, like PyTorch. I would recommend going with that because it has the entire environment built into it, the development environment. But it has like it is a resource intuitive. Like it takes so much of resources from your computer. So if you need an alternative, the text editors like Sublime Text is what I use. It's just the text editor, as the name says. You don't have the entire environment built into it. So you might have to do that outside of the text editor. Coming over to the hardware licensing, yes, like hardware also requires licensing. Certain processors, SoCs and ASIC or FPGAs are designed by some of the manufacturers, like silicon manufacturers. You might have to take permission or like license from them. It depends on the complexity of the processor. The less complex would require certain process like just signing an NDA, which also requires you to have a registered startup. And once you sign the NDA, you have access to those chipsets. And there are far complex ones which require a lot more processes. They go through like what's your orders, like how many quantity do we need, like the MOQ, the minimum order quantity. What's the funding size for your company? So they want to know all these information before they actually release those information to you. So you have to look into your designs and figure out like what are the chips that you need, and based on their requirement, you might have to like meet those requirements. So let's look into the component procurement process. There are different components like passive components and active components. So passive components could be like resistors, capacitors, inductors, and so on. Active components could be like transistors, LEDs, anything energy source related. It could also be like ICs and so on. So how do we like procure it? Where do we start from? So there are distributors to it. There are publicly available distributor who are like authorized to sell a lot of these components in one place. There are companies like DigiKey, there is like Mouser, Avnet, and so on. There's so many of those platforms. The rest would be you had to go through like an unauthorized source if you're not able to find the components within these distributors. The other way is to get to the manufacturer. Like as we discussed before, you might have to sign an NDA, and they would recommend through whom you had to go through. So they will link you to a local distributor, and you have to purchase through them. Or in some cases, you might have to purchase directly from the manufacturer. All right, let's move on to the next one, which is the manufacturing process. We did look into some of these in the previous video. We want to like focus more on the manufacturing side, like after the design, what is the process you need to go through? Or for the design, what are the process you need to go through? So first is the fabrication capabilities. You need to talk to your local manufacturer, like what are their capabilities are, what are their limitations in the design. Some manufacturers have like a limitation with 6 layers, or some manufacturer may have like only 10 layers, depending. There are like a lot of criteria on these things. And the same goes with assembly capabilities. There are, we saw that the resistor, which was like 0201, which is like the smallest one of the smallest resistor, that requires a lot of complicated process. So some manufacturer won't be able to do an O2, O1 size resistors, the smallest resistors. And they may not be able to do BGAs, which are like ball grid arrays like these. So you might have to like talk to them and discuss what works with them, and according to that you might have to make your design, or once you make the design you might have to find the right manufacturers. That's what I did, which is not recommended to do it. Like I would recommend you to go through the manufacturers first, talk to them and like find out the capabilities and then design it. Just for manufacturing process on PCBs, you might have to give the data like the Gerber files, which is basically layer by layer information, and BOM or BOM is called bill of materials. Like in the entire board, what are your components? Like all these passive and active components, what we saw is to be like listed in a spreadsheet, and you had to share this to them so that they can do the procurement, and they also would know where to place those components. There's a pick and place file. And the stack up information is the layer stack up information, like what's the thickness of each layer, what's the dielectric material between those two layers, and what are the via drills, and like from which layer to which layer is the via, and all those information like this what you see here. And then you may have to decide like what we saw here recently, the minimum board size and maximum board size. If your board is like smaller than their minimum requirement, then you may have to like place multiple boards into the same panel. So it could be like one or two or three, 4, 10, and so on. The optical flow sensor, what I have designed, is placed in a single panel with like 10 PCBs like this. And then you may have to also go through the issues, like after the design, certain process, they would do a verification and validation if those design can be manufactured. So once they confirm the manufacturing issues, everything has been sorted out, is when they actually would start the manufacturing process. So until then, there are like certain process, like they would say the stack up would not be what you would require it to be done. So they'll come up with their own stack up information. You might have to verify if that information is okay or not. If not, you may have to find a different manufacturer, or you might have to like make changes in your designs. And then the final issue currently, the year like 2023, we have like all these chip shortages and supply chain issues. You may see certain parts like available like in stock, and you may use that component in your design. But by the time like you complete the design and send it to the manufacturer, and they do the verification and validation of your design, and they start procuring it, your components might be out of stock. So you may have to go through alternates which are like available in the market, or you may have to go through like unauthorized distributors, which sometimes they mark up the price. Like if it's like $50, they would charge you like $70, $80. So you may have to like play around with the pricing there. You may have, because you're already designed and you need these boards, you may have to pay that marked up price. The next in the list is the manufacturing process for 3D printers. 3D printers are of like different types. There are FDM printers, there are resin 3D printers, and there is also metal 3D printers now. So depending on your requirement, what sort of your startups are, I would say 3D printers are the best investment. The second, once you iterate like the prototype version is done and you want to move to the next stage, you can go with the injection molding, and that's where the prices skyrocket. Like the tooling costs are far higher as compared to like 3D printers, and you may have to like go through the same process with the PCBs. Like you may have exceptions and like issues with the manufacturing, so you may have to like modify your designs according to the manufacturing capabilities. I also spoke with another person from these sector. He recommended going with the vacuum-based casting. So I haven't gone through that process. He said like it's really, really good and it's cheaper comparatively. He had sent me some samples. So once I go through those process, I can like show you across that process like how it is and what sort of quality material you can generate with that. And then you have like CNC, which is for metals, for milling or drilling. If you are like involving your hardware with like metals or cases and so on, you can go through the same thing, but the process is very much same as like injection molding or PCB manufacturing. The last but not the least is the tools which I've been using. You may need it or you may not need it, depending on where you are, at what stage of startup you are. It could be like video editing tools, which there is a paid version for Adobe Premiere and Pro and After Effects, which I was using previously. But now I'm like back to DaVinci Resolve. These videos, what you're seeing on YouTube, is all edited on DaVinci Resolve. It is free and open source. It has like tons of tools. I don't think like you might have to go with the paid versions of Adobe as of now, like unless like you're into a professional editing. For basic and like intermediate editing, I would say DaVinci Resolve has like all those features. The next is the photo editing. I use GIMP, an alternate version of Adobe Photoshop again, which is also like free to use, and it has like most of the tools for editing. And I did like all these thumbnails in that, so it's really good. And last is like Blender, which is a 3D modeling. You can actually do rendering on Fusion 360 if you're using it, but if you need like more professional sort of looking renders of your product, then you can go with Blender. So it's also free and open source, and it has like tons of tools and features. So I would recommend if you're like into like a product design or like product showcasing. So that's really nice. All right, so let's get started with the tour. This is sort of the workstation or drone lab, as I call it. As you can see here, this is the Creality Ender 3 Pro, Ender 3 Pro Neo. So this is a LCD screen-based printer. I have upgraded the bed with glass. And I use like multiple materials. This is PETG, I have PLA and TPU, and I print like back and forth with different materials here. As you can see, I have all the tools, mechanical tools like hand tools and some sort of power tools on the table here. All these are magnetic based, so it's all like stuck in there. You can take it, use it, and then like you can snap it off. And I also have like multiple bits for the screwdrivers over here. And I have a electric screwdriver, which is like really good. It doesn't have much torque, but it's super good for tightening the screws rather than like doing it on a hand. So this is a really nice tool. I also have like TS100 soldering iron. I've been using these for like almost 5 years now. I have all the soldering stuff, like the soldering wires, flux, alcohol, everything over there. I also have like a multimeter, and that's a hairspray, not for hair, but for the glass bed on the 3D printer. And here you guys have seen the prototypes already. And as you can see, all the cables connected. I'm just waiting for the flight controller. I should be able to put it on a drone for testing. And here, as you can see, I have an articulated arm for mounting a GoPro or camera so that you can see the top-down video of the stuff I'm working on. And I also have like a really nice magnetic light. And here is all the hardware stuff. It's all in a neatly organized trays here. It's not categorized like exactly, but I know where the stuffs are. There are like wires, cables, connectors, and like XT60 connectors for the drones. It's mostly for the drone stuff here. And here, as you see, I have like an Asus ROG Flow Z13. It's the high-end version of the laptop series. I also have like an external graphics card. It runs 3080 Ti, and the laptop comes with 3070. And I also have like a 4K LG monitor, It does all the swivel. It can like tilt it all the way 90 degrees for programming and so on. And I have like a pegboard custom designed where I can like mount all the tools. I need to 3D print the peg hooks. Like I did like few of these peg hooks, as you can see here. Rest I need to do more. I haven't like completed that. Also have like a glue gun. And this is the complete setup. All right, these are the cool things I've been working on. Hopefully it's cool. There are more yet to come. Like this is just the flight controllers. There are like more drone components under design, like it's under progress, and also have like some of the drone stuff we'll be seeing around. Like have like 3 different drone frames. I need to figure out like which one to use. So that's something we'll see in the upcoming video. Hopefully, when we get the flight controller, we should be able to see more progress, putting it on a drone and testing. As always, thanks for watching. Peace.